Hey, third graders, it is week 9, day 3, last week of school. So let's grab our packets and get started. Started with our warm up. It says draw a line to divide the square into 2 equal triangles. There's 2 really important words here, equal and triangles. We want to make sure that our triangles are the same size. So this wouldn't work for a couple reasons. There's only one triangle and they're not equal. So to do what they want, we're going to draw a line diagonally across. On your paper, make sure you're using a straight edge to make it a little nicer than mine. But now you can see we have 1 triangle, 2 triangles, and they are the same size, so it's half of the square. All right, now let's look at the next one. Divide the triangle into equal, again, smaller triangles. Okay, so again, that doesn't work because this one's not a triangle and one is bigger than the other. So we've got to do it a little differently. So here, let's take a look. I'm going to draw a line right down the middle, again folding the shape in half, and you'll see that I have 2 triangles here. I'm going to use my highlighter. So here's one. Whoa, sorry. Here's one. And there's the other one, and they're the same size. So good job. All right, draw a line to divide the trapezoid, that's what this shape is called, into 2 equal trapezoids. And they gave us a little clue. It says a trapezoid is a quadrilateral. Remember, that just means a shape with 4 sides with at least 1 pair of parallel lines. So just to remind us, parallel lines never cross, and they're always moving in the same direction. So we need, if we cut this shape in half like we just need to make sure we're cutting it into 2 equal pieces so they each have 4 sides and there's 2 parallel lines. So this doesn't work because this is a triangle and this is a pentagon. 1, 2, 3, 4, 5 sides. Won't work. We need 2 shapes that have 4 sides where 2 of the lines are parallel. So let's see. Sorry, trying to get this all erased. All right, we're just going to have to call that good enough. I'll pick a new color. All right, let's see. It's a little easier for me to draw with the highlighter. So let's try. If I draw my line here, oops, just down the middle, pretend it's down the middle, I see that this line is parallel with this line. They're running in the same direction. And my shape has 1, 2, 3, 4 sides. And the same is true for this one. So that's one way we could have done it. They're both equal. Now some of you might have done it like this. Some of you might have drawn your line this way, across that way. The reason that doesn't work is because the bottom is bigger than the top. And remember in their directions they said equal trapezoids, equal sizes. So we have to go right like this in half vertically so that we have the equal trapezoids. So good job. Let's take a look at our new learning. Okay. It says partition the number line to show the fractional units. Then draw number bonds with copies of 1 whole for the circled whole numbers. So those are some crazy directions and we're going to break them down here. Remember that partition just means to cut or divide up. So here is our number line and here are our regular whole numbers at the bottom, 2, 3, and 4. They tell me over here they want this divided in or partitioned into fourths. So I can partition the whole number intervals into fourths. That means I can cut a whole number into fourths, into that fraction with 4 equal pieces, which is exactly what they did here. I can count by fourths to label the fraction. Here's the trickiest part of what they're asking you right now. I need to start with 8/4 because this number line starts at 2. This is, we've talked about this in previous weeks, that our whole numbers can have more than one name. 2 is also called 8/4. If I have 2 candy bars cut into 4 equal pieces, pretend those are equal. Then if I have 2 candy bars cut into 4 equal pieces each, to get 2 wholes, I need 8 pieces. So that's why 8/4 is the same as 2 wholes. So we just start at 8/4 and we count up but from there. 8/4, 9/4, 10/4, 11/4, yada, yada, yada. And we keep it moving. Great, so now let's look at the second step. So then we're just going down and we're saying what the whole numbers equal. 2 equals 8/4. 3 equals 12/4. 4 equals 16/4. And they wrote these 2 different ways. They wrote it using the words, and then they also wrote it as a fraction. That's just 2 different ways to show someone that you understood. Now here's the second part of those directions, our number bonds. These are our number bonds. We've used these with other types of math before. Now we're going to use them with fractions. So it says, I can make copies of 1 whole to represent each whole number. Since the fractional unit is fourths, 1 whole can be represented by 4/4. It takes 2 copies of 4/4 to make the whole number 2. So all we're doing with these number bonds is here's my whole number, and I'm breaking it into wholes, but writing those wholes as a fraction, right? So 2 is made up of 2 wholes, and 4/4 is 1 whole, so I need 2 wholes, 2 4/4. Same thing here, 3 4/4 to make 3 wholes, 4 4/4 or 1 whole pieces to make 4. So it's just a lot of steps to show these whole numbers as in different ways. Let's take a look at the next example. So again, they want us to partition that number line into fractional units and then draw the number bond. So we're just going to kind of try it by ourselves. They got us started, but we're going to test it out together first. So first I need to cut into sixths. So 6 equal pieces. So I'm going to cut 5 lines. 1, 2, 3, 4, 5. That's not the best job ever. Let me just try that one more time. On your paper, it's a little easier. Make sure you're using your rulers. 3, 4, 5. Great. 1, 2, 3, 4, 5. All right. So 0, we can say that whole number as 0/6. We don't have any pieces of our candy bar or anything else because there's none. It's 0. 0 is just always 0. So 0 equals 0/6. Write that in. And now we can just count up. 1/6, 2/6, 3/6. Gotta fill in that whole number line. 4/6, 5/6. Sorry, it's hard for me to write neatly on here. 6, 6. There's our whole number. 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. And there's my other whole number. So now I can go ahead and fill in this chart. 1 whole, is equivalent to 6. Oops, don't write it like that. Hopefully you guys didn't make that same mistake. I don't want to write the fraction because that's not where the fraction form goes. So 6/6. Now here I write fraction form. They got it started for me. 2 wholes equals 12/6. And I need to show with my number bond now. So here I have my here are 2 wholes, or 2 6/6, which would make 12/6, which is the same as 2. For 1, I'm just going to put a 6/6. For 0, we don't really put anything. We put 0, 6. It doesn't have anything off of it. You don't even need to put the 0. Okay. Here's our next new learning example. It says, use the number line to write the fractions that name the whole numbers for each fractional unit. The first one has been done for you. So we're just going to take a look at this. They already did it for us. So here's the number line, and it's got 2, 3, and 4. And they want to know, what is 2 as thirds, what is the name for 2 as sixths, and what is the name for 2 as ninths. That's what they're asking us for this chart. So here's all the ways to say 2, here's all the ways to say 3, and here's all the ways to say 4. It says, I know 12/6 equals 2. See? I can count by sixths to find the other fractions that name whole numbers on the number line. I can do the same thing for ninths. So you could sit and fill out this number line like you did before. You can also count by sixths. So we know that 6/6 is 1 whole. And if we know how to count by sixes, we could say 6/6, 12/6, 18/6, 24/6, and same with thirds and same with ninths. So let's take a look at our example. We're going to try it on our own now. Let me pick a new color. Great. Write the fractions that name the whole numbers for each fractional unit. The first one has been done for you. So they went ahead and thirds is done. Now we need to do sevenths, eighths, and tenths. So just as a refresher for ourselves, we know that 7/7 equals 1. We know that 8/8 equals 1 whole. And we know that 10/10 equals 1 whole. Great. So if we know that 7/7, let's focus here. If we know 7/7 equals 1, we can count by sevens to figure out how many are 2. 7/7, 14/7. What's 7 more? 7, 14, 21/7. This is where our skip counting and knowing our multiplication is going to be so helpful. 7, 14, 21, 28/7. If you're having a hard time with this, you can always, always, always fill in your number line. Okay. How about eighths? So 8/8, 16/8, 8/16. Yep, 24/8. Good job. That would be 3 wholes. 8, 16, 24. Yep, I know somebody said it. 32/8. Great job. Okay. Last one is tenths. Counting by tens is a lot easier than the other two, even I'll say that. So 10 tenths is 1, 10, 20 tenths is 2 wholes, 30 tenths is 3 wholes, 10, 20, 30. Yes, 40 tenths. Awesome job. 40 tenths is 4 wholes. Wonderful. All right, let's keep it moving. So this is our last type of problem that we're going to see on our problem set today. Our last new learning. And it's a story problem. Monica walks 1/4 of a mile Monday. Okay. Each day after that, she walks 1/4 mile more than she did the day before. Draw and partition the number line to represent how far Monica walks on Monday, Tuesday, Wednesday, and Thursday. What fraction of a mile did she walk on Thursday? I'm going to read this problem one more time. We know it's about a girl named Monica and she goes for walks. I want you to listen to the quantities, the numbers that you hear, and what they're telling us, because this problem is trying to trick you a little bit. Monica walks 1/4 of a mile on Monday. Each day after that, she walks 1/4 of a mile more than she did the day before. Draw and partition a number line that represents how far Monica walks on Monday, Tuesday, Wednesday, and Thursday. What fraction of a mile does she walk on Thursday? So you can see they drew this number line and they cut it into 4 equal pieces, into fourths, right? And on the first day, or at the 0, it's nothing, right? This is our starting point. On the first day, on Monday, Monica walked 1/4 of a mile. The next day, she walked 1/4 of a mile more than she did the day before. So she still walked from here to here, but then she did another 1/4 of a mile. On Wednesday, she did the same thing. So she walked the same amount she did Monday, the same amount she did Tuesday, but then she added one more 1/4 of a mile on Wednesday. On Thursday, the last day, same thing. Same amount as Monday, same amount as Tuesday, same amount as Wednesday, and then she added one more 1/4 of a mile on Thursday. So they labeled each day going up by the 4th, and we can see on our number line that on Thursday she walks 4/4 of a mile, which we know is the same as 1 mile, right? Monica walks 4/4 of a mile on Thursday. Because each day she was increasing, she was adding more. That's the key word there. All right, let's try it out. Let's get to our problem set. It says, partition the number line to show the fractional units, then draw the number bonds using copies of one whole for each whole number. Each of the circled whole numbers, I'm sorry. So we're at 0. We're cutting it into half. How many equal pieces are halves again? Yes, 2 equal pieces. Great job. So we're going to cut this into half, 2 1/2. Start here. We have 0 halves, 1 half, 2 halves, which is the same as, yes, 1 whole. Nice work. Okay. 3 halves and 4 halves, which is equivalent to, yes, 2. Nice work. All right, let's fill the rest in. 0 equals 0 halves. We would write that as a fraction like this. And we're not even going to worry about the number bond. All right, 1 whole equals 2 halves. Here's how we write the fraction. For the number bond, we only need to put 1 circle coming off of it. And 2 wholes equals 4 halves. So we need 2 circles off of our number bond with 2 holes in them, because 2 plus 2 is 4 halves. 2 holes. All right, let's move on to our next problem. If you need to pause here to check it over, go for it. Okay, write the fractions that name the whole numbers for each fractional unit. The first one has been done for you. Remember, if you need to partition your number line for each of these, you can. It's going to get messy, and we're going to try to do it by skip counting up here on the screen. Before we start, I'm going to remind us what 1 whole equals. So for thirds, can someone tell me? Just shout it at your screen. How many thirds equal 1 whole? Yes, 3 thirds equal 1 whole. What about for fourths? Can somebody shout that one out? Yep, 4 fourths equals 1 whole. And what about for sixths? Incredible. 1 whole equals 6 sixths. So we're going to say this is what 2 is, this is what 3 is, this is what 4 is. Let's fill it in. Here we go, thirds. So 3 thirds is 1. Let's count by threes. 3 thirds, 6 thirds. Great. Okay, 3 thirds, 6 thirds, 9 thirds. Nice. 3 thirds, 6 thirds, 9 thirds, 12 thirds. Great job. Okie dokie, let's try fourths. Get a new color. 4 over 4. 4 fourths, all right. So 4 fourths, 8 fourths. Good, we're counting by fours. 4, 8. 4 fourths, 8 fourths. Good job, 12 fourths. Awesome. 4 fourths, 8 fourths, 12 fourths. Yep, 16 fourths. You are cruising. Okay, last fraction for this problem. We're going to do sixths. So 6 sixths equals 1 whole. 6. Yep, 6 6, 12 sixths. 6 6, 12 6. 18 sixths. Good job. 6 12 18. And then 6 6, 12 6, 18 sixths, 24 sixths. Nice work. Pat yourself on the back. Okay, here's our word problem. Sammy uses 1/4 meter of wire each day to make things. Draw a number line to represent 1 meter, 1 whole meter of wire. Partition the number line to represent how much Sammy uses each day. How many days does the wire last? So let's start by making our number line. Mine's going to be a little messy because we know that I'm not great at writing on the computer. I'm going to start at 0 up to 1, and now we need to cut it into what unit fraction? Oh, right, fourths, okay? I always like to go half and then cut those in half. Great. Let's label it 1/4, 2/4. Oh, wait, hold on. I wrote my fractions on the wrong side of the number line. I wish you guys were here in person to tell me. So we got to remember our fractions go above the number line. And you know what? I'm going to write my fractions in a fun color. 1/4, 2/4, 3/4, 4/4, which would be 1 whole. So Sammy is a little different than our example problem of Meredith. Each day, Sammy just uses 1/4. So on Monday, he uses this much wire. On the next day, day 2, Tuesday, we'll call it, he uses this much, and now it's gone. Once he uses it, right, it's gone. Okay, Wednesday, okay, Thursday. Oh, and we're out of wire. That was our whole number line. So let's count how many days did the wire last. 1, 2, 3, 4. How many days does the wire last? Let me get my pen. The wire lasts, how many days again? Yep, 4 days. Do you see how I am writing a complete sentence even though it's so hard for me to write on the computer? And do you see how I'm just using the question to construct my sentence? That's what I expect from you. The wire lasts 4 days. Period. All right. How many days will 3 meters of wire last? So how many days, if he had 3 of these, how many would it be? So if you thought about it maybe as a number bond like we did before, or 3 meters, right? 3 meters is the same as 4 4 4. You could think of it like this, or you could think back to our lovely chart. 3 days, 12/4. Is that what our number bond shows? 4/8, 4/4, 8/4, 12/4. Oh, so I'm actually gonna click out and use a text box here. Oh, never mind. So the wire, 3 meters of wire of, sorry for my cursive, wire will last 12 days. Yep. 12 days. And we could even say because 3 is equivalent to 12/4, we could say 3 has 4, there's 3 wholes, there's 3 4/4. That's what we'll say. We'll say because, I'm going to write BC, which means because. BC. Because there are 3 copies of 4/4. That's how they say it, 3 copies. Are 3 copies of 4/4. Period. Make sure you have a sentence on your page. If you don't, please pause here. You can write something down. If you need to look over anything, feel free to go back. But that is it for today, guys. Thank you so much for working so hard. I'm really proud of you guys for working your tails off this year. You've all been so wonderful. Make sure you're still practicing your multiplication facts. I'll link it again because as you can see, all that skip counting is really helpful. But you guys are superstars and I love you and I'm proud of you and we will see you later. Bye.